Gesture control is the cutting-edge technology in gaming. The Kinect motion sensor helps developers to unlock even greater potential in their applications. With Kinect, we'd like to provide an unique experience that allows you to control and play your favorite games in a new way. Now, let's find out how exactly we are able to do this.
First of all, we need to understand how Kinect senses our world. Depth information, shapes, materials, and motion.
The depth sensor is a breakthrough feature of the Kinect and was also the central focus of our research.
Each Kinect contains a RGB camera, a depth sensor, and a microphone array. The depth sensor is combined with an infrared-structured laser projector and a monochrome camera. The projector casts a no-micro pattern of pixels onto a scene. Then the camera uses the deformation of that pattern to calculate the depth information of the scene. Before we acquire any useful information from a scene, the raw data from the Kinect must be heavily processed. If you glance at the scan data from the Kinect directly, you can see it's very rough. We have to transform this data into something more useful. Poisson surface reconstruction helps.
We use the Poisson equation to determine the indicator function from its gradient field. After that, the mesh surface can be easily extracted from the indicator function.
Now, the quality of information is improved, but it's still not good enough. The Xbox 360, released in 2005, now seems to have limited hardware. It will take about 20 seconds using traditional methods to do the reconstruction. It doesn't sound like a very long time, but for a real-time game, even a few seconds will seriously impact the user experience.
The Xbox 360 has a very strong CPU, but its GPU is even more powerful, so we developed a hybrid framework to utilize both of the CPU and the GPUs to do the calculations. Besides the computation, memory is another kind of limitation. In Xbox games, the textures, models, music, and the system, all of them takes memory. So finally, we only have a small amount of space available.
We can furthermore adjust the parameter of this algorithm to reduce 80% of the triangles with little actual change in their shapes. Finally, Kinect can digitize an object in less than 2 seconds. Our current work is the only first step. We are still working on Kinect Object Digitization. In the future, it will become faster, more accurate, and more realistic.
We hope through this effort to enrich the user experiences of the Kinect Object Digitization.